Hello viewers, welcome to Big Boy Physics, and in today's video I have taken up a problem from electric currents. Okay, as usual I'd like you to try this problem for a few minutes and then I'll be presenting you the solution. Okay, so let's get started. The question says that one problem in determining the resistivity of a semiconductor is the unknown voltage drop across the contacts. This problem can be solved using the following model. We analyze here using a semi-infinite thin plate of thickness h for simplicity. Let the four contacts be soldered to the edge of the plate as shown in the diagram below. Current I pass through contacts A and B so that a voltmeter connected between C and D measures a voltage of I rho by pi h ln A plus B plus C into B by A plus B into B plus C. Okay, so you have to basically prove that if I pass current I through A and take out this current I from B and I stick a voltmeter across C and D, you have to basically tell me the voltage measured by the voltmeter. Okay, so the concept behind this problem is superposition theorem. Concept is superposition theorem. Many of you may know about it, and those who doesn't know, I'd like to present you the theorem. Okay, so the theorem says that suppose you have a circuital mesh or you have any body. Okay, and I drive current I inside the body through a contact point A. Suppose this current I later get diffused somewhat like this, but in a symmetrical manner. In a symmetrical manner, this current I gets diffused in outside of the body. It may be symmetrical or non-symmetrical. Generally, we consider it a symmetrical portion. So it may not be symmetrical, but it must fulfill another condition, which I'll be presenting you in the second part. So suppose the total diffused out current is also I, then only the charge conservation law will be holding true. Okay. Consider the same body. I'm trying to draw it exact same. Okay. Consider this body exact same. Okay. Now another point B, which is another lead, and current I is getting driven out of it. Now this same similar and same manner, current the total will be I. This current total, which is equal to I, will be somehow diffused into this circuital mesh, better to say, this circuital mesh, and hence this will be another circuit. Now summing up both of them, that is adding both of them or superimposing one on another. Observe that this current actually gets cancelled with this one with this one with this, and so on. And finally, you will be getting somewhat like this. The current A is driven inside from A, and current I is driven out of point B. So that's it, what we'll be getting. And this way we can say that the voltage applied across the leads U is equal to R effective into I. For those who knows about this, let me give you another example for knowing, for understanding. Suppose you have an infinite wire mesh. This is a problem from Irodov. This is an infinite wire mesh, and it's somewhat like this. Okay, and it goes on. This is another branch, and basically it means that each of the side of the square basically consists a resistance R, and I connect this to a voltage source of EMF E between 2 points A and B. So you have to tell me the effective resistance between A and B. This question is basically done upon by the theorem of superposition. So what will happen here is, consider the mesh again, and consider I is getting driven inside, and through the infinite, at the infinite portion, means when x and y tends infinite or minus infinity comma minus infinity, so current I basically equally diffuses in every direction, that if diffuses, then total current will come out to be I. So I gets diffused inside the circuit through point A. So initially I by 4 will be going through each of the branches. Similarly, we'll be adding this with another circuit where this is lead A, this is B. So current I is getting driven out of B, which is I, and so here current will be I by 4. Now if you add both of them, you will get current I by 2 passing through the circuit or the wire AB through IAB is equals to I by 4 plus I by 4, which will come out to be I by 2. Hence I can say that R into I by 2 is equals to voltage applied. So V by I is equal to R effective, which will come out to be R by 2, and that's the answer. So this is the method in which we'll be applying the concept of superposition. Now coming back to the problem says that you have to apply the superposition only, but in a little different manner. Okay, instead of giving a grid, they have given some kind of a plain sheet. So in this question, I'll be just redrawing the circuit and marking all the parameters. Yeah, this is my infinite sheet, and it just goes on. I don't know where it goes. This is point A, this is point B, this is point C, and this is point D. I am marking with different colors. This is distance A, B, C respectively. First case will be considering I to be driven inside the circuit. So I will be diffused in all the direction evenly. Hence I can say that di by d theta to be I by pi in this case. Hence I can say J as a function of R will be I by this cross section, which is coming to be this cross section. Basically this is a thick sheet, and this has thickness is equals to H. So the cross sectional area will come out to be pi R H. So this will be J, or the current density as a function of distance R, where this forms basically a semicircle. So I can say that E as a function of R is equals to rho J. Rho J is rho I by pi R H by HR. Now observe that its electric field is away from point A. So I can say that voltage C will be greater than voltage D, because the electric field goes from C to D. I am marking with yellow color. Electric field goes from C to D. So I can say VC minus Vd is equals to rho I by pi H ln. So why? Because we are doing an integration. Dr integration from C to D. Now distance of C from A is basically A plus B, and distance of D from A is A plus B plus C. Hence this integration will come out to be rho I by pi H ln A plus B plus C by A plus B. But we are not done yet, because we have only considered the voltage contribution due to the current driven through A only. But what about current driven through B? If current I is again driven out through B, then in this case electric field direction, which I am showing by red color, will be reversed in the direction. Okay, now in this case it will come out to Vd minus Vd is greater than Vc. So I can say Vc minus Vd is equals to rho I by pi H integral dr by R from C to D, but with a negative sign. Or better write it from D to C, because we are going in the opposite direction from D to C. So I can say it to be rho I by pi H ln. What is the distance between B and C? Distance between B and C is small b, and B and D is B plus C. Now what is the net effective voltage? Net effective U is equals to the contribution due to A and contribution due to B. That is contribution due to the ingoing current through A, and contribution due to the outgoing current through B, which will get it to be rho I by pi H ln A plus B plus C into B by A plus B into B plus C. and that's the answer, and they have asked to prove this thing only: a plus b plus c into b by a plus b into b plus c. So yeah, we finally proved this theorem, and that's the answer. Well, they have also given an extract about this where it is used and all those stuffs. Okay, so I guess you can understand a b c all those constants just by observing the diagram only. So I don't think you must have faced problem regarding it. So that's it for today. Hope you learned something new. Thank you. Have a nice day.